13.1, compound interest and future values. So, in some loans, interest is compounded only once during the life of the loan using the simple interest formula. You would have saw this in Unit 11. But in other loans, it's compounded more than once during the life of the loan. And so interest is added to the principal, and then that new principal again gets interest on it. And so that's what compounding means. So there's certain things you need to know about this interest period. That's the amount of time after which interest is calculated and added to the principal. Compound interest is all the interest that is accumulated after more than one interest period. Future value, maturity value, compound amount, this is your principal plus your interest. Period interest rate, that is your rate for the period. Many times you have to take the interest rate and divide it by the number of interest periods per year. So dividing the annual interest rate by periods per year would be, let's say you have 12% interest rate and there's 2 periods, you go 12% divided by 2 to get 6%. The formula I equals PRT, we can calculate interest. And here's again the formula for the interest rate. You take the interest rate over the periods per year. And compound interest is your future value minus your original principal. What would this all look like if we were to try a problem? So our first problem is, you have Susan Riddle's Duke Photography. She secures a secure amount of a loan for $8,000. That means P. 3 years. Your time, T. Compounded annually. What does that mean? Well, annually is once per year, and that is your N. That is your N. And you'll know where all these go into the formula soon. If the interest rate was 9%, so here is your R, find A, the compound interest, B, the compound amount, and B, the compound interest, and then compare them. So here it is. What is the formula that we'll be using? This is actually going back to 9th grade. The compound formula is P parentheses 1 plus R over N to the NT. And that gives you, I guess, amount, we could say. Amount is principal 1 plus rate over number of periods times to the exponent number of periods times time. What would that look in this case? Well, our P is 8,000. 1 plus our rate is 0.09, 9% converted to a decimal. Our N is 1 this time, because it's only compounded annually. Up here, our N is 1, and our T is 3 years. So if you put that in the calculator and compute all of that, you will get $10,360.23. That is your compound amount. How would you figure out how much interest you paid? Well, take out the original loan. The original loan was $8,000. If we subtract that, we'll end up with $2,360.23 in interest. Now, the last thing here says, compare this with a simple interest loan. That would be going back to Unit 11, where we use the formula PRT. Plug it in. P is 8,000. Rate is 0.09. Time is 3. What do we get? Interest of $2,160. So if you compare the two, so this one is simple interest, which we did in Unit 11. This is compound interest. What's the difference between the two? If we subtract the two, the difference is $200.23. So compounding will cause you to pay more interest. It makes sense because they're taking your interest, adding it onto your loan, and then taking it in your rate times that. And that's how almost all loans at a bank works. Let's try it again. Find the future value of a $10,000 investment, so P, at 2%, R, compounded semi-annually. How many times is semi-annually? Think about semi is twice a year. For 3 years. So this is our N and this is our T right there. 3 years. Formula again. A equals P parentheses 1 plus R over N to the NT. It's actually an exponential growth formula from algebra. We plug this in. Principal 10,000. 1 plus rate 0.02 over N2 to the N2 times T3. So just substituting all my numbers into the formula. Type this all in my calculator. You can put this all in your calculator at once. Write it just like I have it with the parentheses and use the fraction tool here and you will get this. Your answer is $10,615.20. Okay, go ahead, pause the video, try the stop and check, and then I will go over them for you. Okay, question. Find the monthly interest rate on a loan that has an annual interest rate of 9.2%. So the monthly rate, if we look up above in those formulas in the beginning, you take the annual interest rate and put it over the number of interest periods per year. So if they give us a rate of 9.2% over the periods per year, well, if it's monthly, how many periods is that? 12. There's 12 months in a year. What does that give us? You make sure to convert to a decimal and then back to a percent. The answer is 0.767%. Okay, now we're going to use our new formula. P parentheses 1 plus R over N to the NT. A equals. So what is it? Principal 2,950. 1 plus rate 0.08 over compounded annually once. So that's a 1. To the 1 times T, it says 2 years. What do I get? $3,440.88. Find the amount of interest. Well, I got to subtract the original loan to get my interest to be $490.88. So that's the amount of interest. So this is my future value right here. This is my interest. Do it again. A equals P parentheses 1 plus R over N to the NT. What is my principal? 20,000. 1 plus rate 0.035. Compounded semi-annually means 2 to the 2 years. Answer $21,437.19. Okay, last one. Formula. A equals P 1 plus R over N to the NT. So principal 15,000. 1 plus rate 0.028 over semi-annually means 2 to the 2 times how many years? 3 years. Answer should be $16,304.93. So that is the first part of our lesson using that formula to find the future value when something is compounded. So it would be tedious and time consuming to calculate a large number of periods with the previous method. So table 13.1, which is the future value or compound amount of 1, find the number of periods and the rate per period to identify the value by which the principal is multiplied by. So 13.1 is right here, the table for your values. You see the rates go across the top and your periods go down the side, and you just find which value it is. So if we take a look at the first question that deals with this, is example 3. It says use table 13.1 to compute the compound interest on a $5,000 loan for 6 years compounded annually at 8%. How do you start this? You must find your interest periods and figure this out for your interest rate. So how many number of years is this loan for times how many interest periods there are. So this loan is for 6 years times how many periods? Annually is your period. Annually means 1. So that means we have 6 periods. Now, to find your interest rate, your period interest rate, that is your annual interest rate over interest periods per year. So in this case, it would look like, what is our annual interest rate? Up here, 8%, over how many interests per year in this case? We found that to be 6. So we have how many periods per year there are this year? Oops, sorry, is 1. There's only 1 interest because it's annually. So our rate stays at 8% in this case. It does not change because we're only doing 1 period because it's annually. So now we go to table 13.1. We have a rate of 8% and 6 periods. So I'm going to go to 8%, which is right here, and I'm going to go down 6. So right here, 6. If I go across and down, this is my number. Lovely to read, right? So I'm seeing 1.58687. How does this work? Well, that number, you multiply your principal by it. So 5,000 times 1.58687 gives us $7,934.35. That is your future value. This question says compute the compound interest. Well, subtract your starting loan to find your interest, and there is your interest. Let's try it again. We have an investment of $3,000 at 4% annually. Is compounded quarterly. That means, think about quarters in a dollar, 4 times a year for 3 years. So we've got principal, we've got rate, we've got number of periods right here, and time right there. Find the future value. Always start off by finding your periods. That is your years times how many times it's being compounded. And that's compounded. So this one, in this case, it's 3 years compounded 4 times, means periods is 12. Once you have your periods, then you go to your rate. Your rate is your percent, which this case is 4%, divided by your periods. It's compounded. How many times is it compounded again? 4 times a year. So what is the rate on this one? 1%. So now we go back to the table. This time we're looking at a 1% rate, 12 periods. Up I go to the table. 1% right here. 12 periods right here. Go across, go down, there it is. Okay, so I'm going to bring that number down to the question. So the number is 3,000, my principal, times table value 1.12683. What does that give me? $3,380.49. That's my future value. Subtract the original loan to get myself my interest. And there are my answers. So using the table, you must have your periods, years times how many times it's compounded, and your rate, percent divided by how many times it's compounded, to go to the table to get the value to multiply it by the principal. Okay, go ahead, click on the stop and check, pause the video, do the stop and check, and then come back to the video when you are done. So here is that formula that I've been showing you, except I have a little more in it with the R over N to the NT. Example 5, let's use that same formula. We're just practicing it still again. So amount equals principal 1 plus R over N to the NT. How does this work? Principal, what is our principal? Right here. Oh, I'm writing a 5. Principal. What is our rate? Right there. What is our time? Right there. How many times is it compounded? Question. Monthly. How many months are there in a year? 12. So that is our N, number of periods. So it's 5,000, 1 plus 0.06 over 12 to the 12 times 3. Plugging in every single thing. What's that turn out to be? $5,983.40. You try example 6, pause the video, try it, and then come back and you can see my work. Okay, here's my work. A equals P parentheses 1 plus R over N to the NT. Here's my P, here's my R, here's my N of 12, and here's my T. Plug them all in. 3,500, 1 plus 0.045 over 12, 12 times 4, and answer for future value, $4,188.85. And it's asking us find the interest, so I have to subtract the original loan to get interest of $688.85. Now they like to do a lot of comparison questions with this too. So you've got this guy, he can do 10,000 at 8% compounded quarterly for 2 years, or he can take 10,000 at 8.2% compounded annually for 2 years. Which is a better deal? So what you have to do is you just have to compute this twice. Use the formula twice, do both situations, compare. Go ahead, pause the video, and try it. Okay, let me start with the first one. 10,000, 1 plus 0.08 compounded quarterly means 4 to the 4 times 2 years. What does this one end up giving me? $11,716.60. Do the second situation. 10,000, 1 plus 0.082 this time, compounded annually, that's a 1. 1 times 2. What does that give me? $11,707.20. So which one is a better deal? And it says in all other conditions, which deal should he take? If I'm at 11,716, 11,707, this seems like the better deal. Okay, go ahead, click on the stock and check, pause the video, do it, and then come back. Okay, effective interest rate is also called the annual percentage year, or APY, when identifying a rate of earning an investment. It is called APR, annual percentage rate, when identifying the rate interest on a loan. Effective rate is the equivalent simple interest rate that is equivalent to a compound rate. How do we find this? We have Marcia. She borrows $6,000 at 10% compounded semi-annually. What is the effective interest rate? Start off, like any other problem we were doing before, you take your rate over periods. So in this case, we have a 10% rate over compounded semi-annually means 2 periods. So that gives us 5%, or a 0.05 period interest rate. Now, from there, what do? What we're going to do is we're going to figure out how much interest she must pay after the first year, and then go from there to find our rate. We can use our formula, A equals P parentheses 1 plus R over N to the NT, to find out what the loan is after 1 year, to subtract it from the principal to get our interest. So in this case, we've got $6,000, 1 plus 0.10 divided by 2 to the 2. Now it's only for 1 year, so it's a 1 for time. What does this give us? $6,615. So if we subtract the original loan, interest on this loan in 1 year is $615. Why do we need this? To find the effective annual interest rate, we must put the interest over the principal times 100%. In this case, interest of $615 over principal of $6,000. What does that end up giving us for a rate? 10.25%. Now, where do we go from that? If we go back and use the table method, we could find this as well. But this way, I think, is the easiest way for you. Okay, so stop and check again, pause the video, try the questions, come back, and I will go over them. Okay, first stop and check. Find the rate. So first of all, we need to start off by finding how much this loan will be after it's compounded 1 year. So we've got $2,800. 1 plus 0.08 over semi-annually means 2 to the 2 times 1. So how much is this loan going to be? $3,028.48. If I subtract the original loan, that's going to give me the interest of $228.48. So then I go and take the interest over the original loan and times it by 100 to get my percent, and you should have gotten 8.16%. Okay, next one. We've got what? 82,500. 1 plus 0.02 semi-annually means 2. 2 times 1. Go ahead, type that in your calculator if you haven't already. That gives me $84,158.30. Subtract the original loan. That gives you $1,658.25. Now you take that, which is your interest, put it over the original loan. Make sure you multiply by 100% as well to turn it into a decimal, a percent. And you get 2.01%. Okay, last one. 5,000. 1 plus 0.03 over 2 to the 2 times 1. What do we get? $5,151 and 125 technically. Subtract 5,000. That gives us an interest of $151 and 125. Take that, put it over the original, multiply by 100 to convert it to a percent, and you should get 3.023%. Okay, we are finally there. Last example. So we've got table 13.2. That gives you the compound interest for $100 compounded daily using 365 days a year. Exactly like using table 11.2, which we did in unit 11, which gave us simple interest on $100. So we are going to use table 13.2 to complete this problem. So what would this look like? Find the interest rate on $800 at 7.5% annually compounded daily for 28 days. What in the world do we do here? First of all, you have to take any time you get your principal. You're going to take your principal and divide it by 100 because these tables are based on units of 100. So in this case, our principal is $800. If we divide it by 100, that means we're going to have 8 units here. So now we have 28 days. We have 7.5%. Let's go and see where that falls on the table. So 7.5%. That's right here. And then we have 28 days. That's right here. So we intersect right there. That's our lucky number. That number, bring it down to the question, is 0.576941. What do you do with that? You multiply it by these units. What does that give you? $4.62. Pretty simple for that question and all of these questions. Just remember, always take principal, divide by 100 to get your units, use your table, and multiply by your units. Okay, go ahead, click on that stop and check, complete it. When you're done, you are done with this lesson, and you may start the homework.